All right, so I'm going to talk quickly about the pulley systems here. This is the third of our series of simple machines, the third of 6. A pulley is essentially a lever or a wheel and axle. You can look at it either way. It's a wheel with a groove in the rim. As you can see right here, there's this little blue wheel in here with a groove in the rim. And what its job is, a rope or a cable has to go through there. And it allows you to lift up weights or move things around. The little loop at the top of the pulley system here, the pulley, is for fastening the pulley either to a fixed location, such as hanging it from a ceiling or a garage or something, or you can simply take this loop and fasten it to your load and use a combination of pulleys and something called a block and tackle that will change your direction and your magnitude of force. So pulley ideal mechanical advantage is very simple. If it's a fixed pulley, think of it as a first-class lever with an ideal mechanical advantage of 1. All that's happening here with this pulley system is we're simply changing the direction that the force moves. Okay, so if I pull down on this arrow, the weight will go up. And that's it. Because this is essentially a first-class lever here. It's going to take me 10 pounds of effort force to move the 10-pound resistance force. A movable pulley. Think of it as a second-class lever with an IMA of 2. The force directions stay the same. Let's move this over here. The force directions stay the same, but what happens is now I've got one end of my rope or my cable anchored to something. It comes down through the system, down through the pulley, and I'm pulling upwards on the tag and the loose end of the line there. If I attach this pulley to the 10-pound weight, because I'm using this movable pulley, I actually only need 5 pounds of force. And the examples that we use in class was a 10 Newton weight and 5 Newtons versus the the non-movable pulley, which was significantly harder to lift. So that's it for those two. Pulleys in combination. Fixed and movable pulleys in combination is called a block and tackle. They provide a mechanical advantage and a direction of effort force or movement. This is important. A single rope or cable is threaded multiple times through a system of pulleys. A pulley IMA is going to equal your number of strands. Here's what I wanted to talk about. Your single rope. So you can see right here, it's tied. It comes down, comes through, comes over, comes down, comes through, comes over. So that's one single strand. You have to have one single strand. Pulley, ideal mechanical advantage. For levers and wheel and axles and other simple machines, you actually have to measure the distance that something, the distance from a fulcrum or the distance, the diameter or circumferences of axles. Here, we're simply counting the strands that oppose the load. So if I take a look at this black one on the end, you will see it does not oppose the direction of load. Okay, it's moving the same direction that if none of this was connected, the load would fall down. This is going down. So again, we don't count that one. So the IMA of this pulley system, if we count the strands, is 1, 2, 3, 4. And hopefully that showed up and you could see it. Pulley AMA, exactly the same as everything else. We need to know two forces. So we have an 800-pound force. We have a 230-pound effort force. Excuse me, 800 is our resistance. That's how much we're lifting up. We can do it with 230 pounds of effort force. If we simply divide those two and using our AMA formula, we come up with an actual mechanical advantage of 3.48 to 1. Okay, so basically what this is doing is it's taking that force and multiplying it by 3.48 times. Okay, the disadvantage to this system, the trade-off, is the amount of rope I have to pull through the pulley system. Okay, so if I wanted to move this weight upwards 1 foot, I would have to pull on 3.4, like 3.5 feet of rope to do that, which doesn't seem like a big deal until you have to lift this up 20 feet. and then you're dealing with like 60 or 80 feet of rope. Winding that around, keeping that on a winch drum or something, or just pulling it with your hands and keeping it all at your feet. So there's your trade-off. Efficiency, we've covered a little bit. It's what you get out versus what you put in. AMA is what you get out. IMA is what you ideally put in. The efficiency of this, because our IMA is 4, because we have 4 strands, is 3.48 divided by 4 times 100 gives me an efficiency of 87%. Okay, so you can see there's a lot more friction loss in the pulley systems because they have a lot more contact points. Okay, a lot of locations for frictions to cause problems. Common misconceptions is that angles don't matter. Well, that's not the case. Angles absolutely do matter. If I look at the picture of the pulley on the left, that's true. If I look at the picture on the right with the strands going out at an angle, you actually need more force. There is a mathematical calculation using some trigonometry where we can actually find out the forces in the x direction and the forces in the y direction. We're not going to do that at this point in time in the year, so just keep your strands straight. See if I can hide this. And number of strands opposing the load only if strands are opposed and parallel to the resistance force. So that's what we're talking about here. This IMA requires trig. If you really didn't want to get into the trig, I can show you, but I'm not going to do that with the whole class. Common misconception. Count the effort strand if it pulls up. No, the number of strands opposing the load. Okay, count a strand if it opposes the load or the load's movable pulley. It might pull up, it might pull down. Okay, for example, this right here, very similar to how garage door works. I've got this anchored on the bottom. I've got 80 pounds of force that I want to pull downwards. Maybe that's on a spring, or maybe there's another pulley or something up here that I'm pulling on. That definitely counts as a mechanical advantage of 2. Pulleys in combination. I'll keep this going for the video, but I stopped here in class, and I will stop here in class. So with separate ropes or cables, the output force of one pulley system becomes the input of another pulley system, and this is called a compound machine. When you have multiple pulley systems with different ropes or cables, separate ropes or cables. So the IMA of the pulley system on the left is we have to take and figure the IMA of each one of these pulley systems individually, and then multiply them together. Okay, so we can't just add it together. Because it's a compound machine, I need to multiply them together. So there's a mechanical advantage of 2, there's a mechanical advantage of 2, and there's a mechanical advantage of 2. So 2 times 2 times 2 gives me 8. So this right here would give me a mechanical advantage of 8. Compound machine. One simple machine is used after another. The mechanical advantages multiply. So here you can see we have a second class lever with the weight in the middle. We've got a pulley system on one end that's fixed. But the strand is fixed, but the pulley is movable. So we have a mechanical advantage here of 2, and we have an IMA for the lever. I can't see the bottom of that. It looks like 12 feet. So we have our 2 times our mechanical advantage of 3. That tells us the entire mechanical advantage of this whole entire machine is 6. Okay? And there's our images resources. So that's it for this whole presentation. We are halfway done with simple machines. I'm not going to have you build anything with Vex. I'm going to actually take you outside, and you're going to try to lift me up using a block and tackle system, which we're going to put out in the cage. So let me know if you have any questions on this pulley stuff. Thank you.